In this session, we're going to be looking at question 3 of the physical properties worksheet that you were given. You can see which exam paper it was taken from, so let's just dive right in. The graph below shows the boiling point of alkanes and alcohols as a function of the number of carbon atoms per molecule. Now, there's two things we've got to take into consideration here. All right, we're looking at boiling point. That means we're going to be looking at intermolecular forces. We've got alkanes and alcohols, and we've got carbon atoms per molecule. So there's two things we can compare here. We can compare functional groups and we can compare chain length. That's what we're looking at. So we look at the graph. It's a fairly simple bar graph, nothing too exciting about it. The first question, though, is they ask us is what is the relationship between boiling points of alkanes and the number of carbon atoms in their molecules as shown in the graph above. So if we look at this, here's the alkanes, it's these ones, okay? And as the number of carbon atoms increases, so does the boiling point. So that's the first question, okay? And we're going to get rid of all of those little nonsense thingies there. Okay. Get rid of the line. There we go. That's what we wanted. Okay. So we need to answer these, okay? Let's just get rid of all of those as well. And by magic, they have disappeared. Okay. So we're looking at the first question. All right. So we're going to write the answers in. So this is 3.1. And what was the relationship? So boiling point increases. Now I'm going to do it in shorthand just because it's quicker and easier. Okay, as the number of carbon atoms increases. Straightforward. Let's move on to the next question. So, next question says, refer to the intermolecular forces to explain the answer to question 3.1. Now, this is really, really important. You have to mention intermolecular forces. Now, because it's all alkanes, they've all got dipole-dipole, so they've all got London forces, which means it's not about the London forces as such. But here, what we need to remember, okay, is that this is here, what they're wanting here, okay, is as the number of carbon atoms increases, okay, this means that the surface area increases because we've got a longer chain length, okay? If the surface area increases, then that means that the intermolecular forces, please remember in your exams you have to write up the word intermolecular forces, the intermolecular forces will also get stronger, okay? If they get stronger, then that means more energy is required to overcome, okay, I'm going to run out of space here, but we'll just go with it, overcome or weaken the intermolecular forces, which means that the boiling point will increase, okay? Please don't use the word break. Cannot break intermolecular forces. You can only weaken them or overcome them. All right, next question. Ethane and ethanol, respectively, are respectively the alkane and alcohol that contains 2 carbon atoms per molecule. How does the boiling point of ethane compare to that of ethanol? So we go back to the first one. We're looking at ethane and ethanol. So we're looking at those two. The first graph is the ethane. The second one is the ethanol. You can see from the graph that ethane has a smaller boiling point than ethanol. And I'm going with the smaller boiling points. They want to know, how does the boiling point of ethane compare? It's lower than. Okay? Then they want the names of the 2 types of intermolecular forces that exist between ethanol molecules. There's 2 here. This one's really important, okay? So here, because it's ethanol, we need to recognize that ethanol is going to have hydrogen bonds and van der Waals. And specifically, it's going to be dipole-dipole. Okay, because it's a polar molecule. Then they say to refer to the type of intermolecular forces to explain the difference in boiling point. Now, this is where you've got to be really careful how you actually write this out. Okay? So, we're now looking at 3.3.3. Okay, so we're going to write this out. First of all, with ethene, okay, there are weak London forces. Very important. Okay, there are weak London forces. With ethanol, there are stronger dipole-dipole and hydrogen bonds. So what that means is this: more energy is needed to overcome the hydrogen bonds. Therefore, higher boiling point. Straightforward. Really nothing that difficult about those, okay? You could have also answered that as being or less energy needed to overcome the weak London forces for the ethane, so it has the lower boiling point. Okay? Great. Next one. Which one of the following, ethane or ethanol, will have the higher vapor pressure? Remember, vapor pressure and boiling point are the inverse of each other. So if something has a high boiling point, it'll have a low vapor pressure. So now we've already realized, okay, so we've already done this, that we know that ethane had the lower boiling point, so it will have the higher vapor pressure. Okay? Viscosity has the same trend as boiling point. The higher the boiling point, the greater the viscosity, because the intermolecular forces are stronger. That means the viscosity is greater for ethanol. Really not so bad. It's just being able to identify the intermolecular forces.